Welcome to the Houdini HOULY Challenge Series. So, SideFX is holding a 31-day challenge where artists create a piece per day based on a daily topic. I've decided to take on the challenge and record each day's work so that you can see the process. I'm doing this so that I can challenge myself, and I'd recommend that you do the same. So, let's get straight into it. Yo, so today is day 7, and day 7's topic is speed. The original idea was some sort of vaporwave speedometer that flings neon paint, and that idea was cool. I don't actually know why I didn't do it. But anyways, I changed to a sort of hadron collider, car driving through a tunnel, wisp binary star system.
What? Bro, what are you talking about, man?
It was inspired by a whole bunch of things. Let me take you through the setup. So I've already finished this. The last 2 days have been pretty crazy. So there's going to actually be 2 videos tonight because I didn't release one yesterday. The reason I didn't release one yesterday was because I was busy with this, plus the current day's work. So it was speed, and I'm also working on falling. Falling turned out to be extremely complex, and so it ate up a lot of time, and I didn't manage my time properly. So unfortunately I can't show you a time lapse, but I'll go through it with you. And it's going to be the same case for falling, but you know, taking you through the setup is actually probably better if you want to learn something. So I'm going to show you this. It's actually very simple. This one is super simple. I have these 2 initial points. Basically, one point gets fed into a solver, and you can see that he goes flying off into the distance. If you put a trail node on it, it's basically just 2 points flying around each other. I made a basic solver where as they move along the x-axis, they spin. So it controls sine and cosine, and that controls their y and x position. And then I add some noise, so you end up with this, where it's sort of like a bit less uniform, so it's just a bit more interesting. And as speed increases, you divide your amplitude for your waves by the speed, so that when they speed up to this really, really fast point over here, they basically just become one straight line, and then they shoot off. Spiral, 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 they come together, shoot off. Add some attribute noise to that, so that the movement is less predictable. So each one has some noise in its movement now. And then basically take that, copy to points. So you have 2 spheres like this, right? So these 2 now spin. I do some attribute blur stuff so that when they close together, they sort of fuse, their positions mix. That's just done by transferring an attribute. Each one has an attribute on it. It transfers back and forth. And then you use that, called proximity, to blur. So this one's position moves closer to that one moves to this one based on proximity. You can see over here, proximity is a driver for a linear interpolate between current position and a position of a point that it finds on the other circle. So proximity divided by 2 so that they meet halfway, right? Okay, so then you attribute blur it so that their movement pulls towards the center a bit better. And then this over here is kind of interesting. So what you do is put this into a solver. So what you figure out with the solver is when these points are basically together. And then what you can do with that is create impact points. And I'll show you those points. Now, as you can see, those are all points of impact. These are all the points at which those are impacting. And then you just take the first one, right? So that's the first impact point. And what you can use that for is a blast wave. So you know now that at frame 190 is where they impact. So then you can create this over here at the impact point. That's just a bunch of scattered points with velocities. And then you can feed both of those, so the original spiraling points, plus that impact point, to a popnet. What the popnet does is it just generates some particles for you, so you end up with this. Right, so that's the impact. It starts out with just these 2 spinning, and you can actually watch them go. And then at some point they impact. Right? So now you have this impact, this shockwave, and you have these points to trail from. I make dust out of these, so it's just a simple particle render. Nothing fancy over there, you just divide emission by age, so that as they age, these particles dim. And then over here, you just have this. Originally, I had a very complex setup, and then it turned out I didn't like it. I can actually show you what it used to look like. If I still have it here. Yeah, unfortunately I deleted what was here. It was a bit weird, but I decided to rather go for this over here, which is a shattered glass at the impact point. So once again, using that impact point that it finds. So my solver finds the point where they impact. Take the first one, create this shattered glass. Super easy to make the shattered glass. You just copy a circle to the point, then you put it through a material fracture. That's RBD material fracture. You set the material type to glass, and the point that you feed it is that impact point, so at the center. And then all you have to do is exploded view that, and then I take those shockwave particles and transfer an attribute onto this shattered glass. So what ends up happening is you can delete based on where the shockwave is. So your glass ends up like this. So it goes impact, small area, grows out, right? So it's like it's shattering. And it ends up being very subtle. So subtle, in fact, that I didn't even notice it. I can show you the original render before I comped it, and you can see what I mean. Here you can see how it goes. It's going to take a second to load. Okay, so we know that it impacts at 190. So let's look for 190. There, right? You see that glass? That's the shatter thing that I was talking about. But it only exists for like 5 frames. And so if you play that back, it's negligible. You barely notice it, which is kind of unfortunate because it's a really cool effect. So this is actually what took up a lot of time. But before I get to that, I actually want to mention one more thing. Pro tip, if you want ridiculously long render times, which result in horrendously noisy images, then do what I did and put a whole lot of small lights in an enclosed space without a main light source. It is a terrible idea to do something like this. What happens is renderers shoot out rays. More light sources equal more ray sources. More ray sources equal more calculations. Then parent that with the fact that your environment is closed. Originally it was completely closed at the top. When it is completely closed, the rays that the light shoots out bounce a bunch of times. And because it's bouncing more, it has to calculate more. And basically what that results in is a very noisy, grainy image. You can see over here that is not a clean image. I had to degrain afterwards, and it really reduced the fidelity of the render. Compare that to something like the swing render, which I can show you here. All right, have it over here. Compare it to this one's noise pattern, and you can see that it's a massive difference, right? Just comparing these two noise patterns. You can see over here, complete mess, but over here, really good looking, right? Super clean render. And the interesting thing about this is this one over here took about twice as long to render per frame. Try to keep your light sources large, try to keep them few, and try to make sure your scenes are well lit and not closed up. It's the reason shots like this look very realistic as well, because what happens is you end up with a very crisp image. So my advice, try to do this, but you know, sometimes you have to go for a darker image. Anyways, so as I was saying, I wasn't happy with that short shatter. So what I did was I created basically a second fracture. And it was actually in another file. It was a duplicate of this file. I think it was called like speed shatter or something. I just duplicated the file and made a slower shatter. Anyways, I want to show you what that looks like. That is just an emission layer. So I'm bringing it over here. So you can see what I did was I told the renderer to mask. So it's called a matte. You matte the tunnel. So as you can see, the tunnel still exists. All it's doing is it's cutting out the fracture area, right? So this is that same camera move. It's the same shot. It's the same frames, 190 to 240. But now you end up with this fracture. And this is where it gets interesting, right? So if you're not familiar with comping just means compositing. What you're doing is you're compositing more than one image together. You're putting images together. Usually it will be with render layers. So add your reflection plus emission plus specularity to your diffuse. Alternatively, you can do fancy things like what I'm about to show you. So you take this, right, this overlay, which is just an emission layer. So it's just black and white, which is really good for comping, because comping, you tend to want masks. Masks are basically just any images where it's like black or white or two varying alpha values. You basically just want two values that can separate. So black and white's good. Anyways, you go over to composite view, you have this, right? This is what was rendered out. I degrain it, so that removes some of the noise. But the issue with degrain is it also makes it look soft, right? It looks hazy, it's not crisp anymore. Anyways, that goes into post effects. That gives you some nice blur on the lights and just a little bit of color correction. This is where it gets a bit interesting. So we have this over here, right? That I just told you about. I transform it down slightly, invert its color, composite, then invert that, so you end up with this. Now I think this looks pretty cool, but you don't just add it or anything. What you do is you use this as a mask for a deform. So I'm going to show you the other side first. So this, I add the sky. This was transparent at the top. I added a black background. You hit it with a contrast, and this is actually keyframe. Same thing with the bright node over here. It hits, becomes very bright, and then tapers off. Then the more interesting part, I use a deform with a noise using this glass shatter. So you have this glass shatter, and I have a noise. The noise drives the deformation. The glass controls where it is. So I don't know if you can see over here, but there's slight deformation. And if I remove the mask, you can see that the deformation is everywhere, right? It goes from this to slightly deformed everywhere. But when you use that mask, it only deforms where that mask is. So that's pretty cool because now it's very subtle. Then I do that thing that I showed you earlier with this, use it for a second deform. So now you're also deforming on the edges. Now it looks like glass, right? But it doesn't really look like glass. It looks more like reality sort of fracturing, and that's what I wanted. I wanted it to look like reality was fracturing. Unfortunately, you lose the effect, and it doesn't look amazing. Also, the render doesn't really draw focus to this. Overall, this could shine a lot better in a different setup. That's basically what I'm getting at. But I think you should try it. It's a pretty cool concept. If you do want to try it, hit me up on Instagram or something, and I'll check out what you made. Anyways, after that, you do a post-process for lens flare, and what you end up with is some nice lens flare and some rings on the edges. Look, don't go crazy with lens flare. I did this because it's kind of sci-fi, but it's not very realistic, actually. And you don't want to Michael Bay everything that you touch. It's a bit, I don't know, I don't want to say tacky, but it's kind of tacky. So don't go too crazy with lens flare. Impact point actually creates some interesting looks. As you can see, there's lens flare on the edges. There's really bright spots that lingers for a bit. Yeah, so you end up with that sort of thing. It's a fun way to add an effect after the fact. So a lot of the time people think that they have to do everything in the render, right? That the render has to look good. That's not true. Compositing is its own art. Like, you can be a compositor where this is all that you do, where you just layer images and you add things to images, you adjust color. It's a big job. And anyways, after I've done all of that, I output it so that you end up with this. By the way, if you want a viewer for your EXR files, if you do happen to be rendering to EXR, which I feel like you should be if you're getting serious about your renders, render to EXR. Don't do PNG or JPEG. PNG or JPEG's fine for, just test shots, quick knockout shots, or for like flipbook kind of things. But for final renders, try to do EXR, because you can also do AOVs, which allow you to separate things like your diffuse and your specular and your emission. Usually you would separate this emission, right? So these two spheres would be separate, all these lights would be separate, and then the tunnel would be one thing. And then you add them together, which would mean that you could do things like changing the brightness of these orbs without changing the brightness of the tunnel, which is pretty cool. That's not all you could do. There's loads of things that you can do in compositing. Anyways, this is what you end up with. I'll also show you the video with the sound because I find that pretty cool. But if you, as I was saying, right, I got distracted. If you want an EXR viewer, you can get DJV for free. I think it's called DJ Viewer. Just look for that little icon. It's a reel. It's pretty cool because you can also do image controls in here, so you can test out your different colors and things, so you can mess around with brightness and that. Kind of get a quick idea for what you want. So it's pretty nice. And you can also view layers in here. I don't think I have any layers to view, but you can. Anyways, it does this. they hit together, and there you can see that glass shatter. So, this could have been better. I wasn't entirely happy with it. Also, it was very noisy, but it's kind of cool. It's pretty, it's nice to look at, and I think it's a bit different. I mainly want to mess around with the cop effect, so the compositing operators in Houdini, and they work pretty well. You can do some interesting things with them. Here you can see that glass effect where it's deforming. It's not actually there, which is cool, right? It's all added afterwards. So there you can see this. It looks like glass, which I really like. Anyways, that's it for this video. Apologies, this might have been a bit boring. I'm sorry. I came out guns blazing on the first week, and I'm slightly regretting it now because I might have set my own standards a bit too high. So now every time something goes wrong, I get really upset because I feel like I could be doing better. But this is really good, this challenge. It's making me a lot more well-rounded. I'd suggest you try the challenge as well. Also, great news. I forgot to share it with you guys. The water effect won day 3, and there's also going to be a tutorial for it. It's the most voted in the community, so a lot of people wanted to see a tutorial for how to do the fish that turn into water. So there'll be a tutorial for that at the end of this month. That one won on day 3, and it's currently in first place for the weekly people's vote. If you want to go check out that vote, it's on the SideFX website under the HOULY forum stuff. I'll leave a link if you want to go check it out. And if you want to leave a vote, you don't have to vote for mine. Like, I'm all about fair game. Vote for whoever's you prefer. And then Swing also won. the one that gave me so much pain. Oh, it didn't win. It came third. But podium finish. I'm happy with that. Your engagement on all these videos has been awesome, so thank you for that. I actually still have to go record the falling video like right now. So yeah, I'm going to record that, and I'll see you guys tomorrow or later or whenever. Bye.